You guys ready? Which graph has the same minimum as that parabola? Does this parabola that is graphed in front of you have a minimum? The answer is yes. And what is that minimum? Can you tell this to me? Does the graph have a minimum? What's the lowest number that thing goes to? -9. I agree. Good. So let's look at the options.
Oh, is that just the lowest point?
Yeah, the minimum means the lowest point. Let's look at the options. They told us is y equals -x squared minus 9. Does that have a minimum at -9? Okay. Graph this in your head. You guys can do it. What does a negative do? Flips the parabola upside down. I agree. Yeah, it makes it a sad face. I agree. What does the -9 do? It pushes the whole dang thing down by 9. So if I were to graph this, something like that,
Okay.
right? Does this have a minimum at -9? Nope. Does it have a minimum at all?
No.
No.
It just keeps going.
It can keep on going down. Does it have a maximum though?
Yeah.
Ah, and the maximum does happen to be at -9, but that is not this is not a good candidate for our problem because we want a minimum at -9. So let's look at the other option. All right, I've got x squared plus 9. Let's try that one. X squared plus 9. Can you graph that? In your head, can you visualize it? Is it a minimum at -9? Does it have a minimum? Yes, it does.
Wait. Oh, 9 is
That minimum happens to be +9 because you're taking the regular parabola and just pushing them up by 9.
yeah.
So it does have a minimum because it does have the lowest point that it goes to. It's just at +9.
Mhm.
We cool? What about this? -x squared minus 6x. Gosh, I realize this actually isn't as easy as I want it to be. Okay. There is another thing trick that I forgot to tell you. Actually, yeah, I agree, Sophia. For this particular problem, here's how I would cheat. You have access to a graphing calculator on this problem. I would graph out all of the different ones and see which one has a minimum of -9. Now, there is another trick, though, that I can show you, and that is to do this. No. I'll show you what the trick is, okay? So you could graph it, and there's your answer. But there's this thing, and I talked to you guys about it before. What was the quadratic equation? All right, it was it was -b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Is this where I'm going with this? No, this is anyway, this is not in that special form that's easy to graph off the top of our head. We cool? This is not in that special form. I wanted to make it into that special form. And in order to do that, I would need to do that trick that I showed you once before, called completing the square. Okay? Now, in the completing the square trick, we we made this positive, positive, and negative. We want this number in front of the x squared to be 1. Okay? And then we took this number over here. We called that the b term. And we said, all right, what is b over 2 squared? Right? So b over 2 is b over 2 is 3, and then squared, that's 9. And then we subtracted 9 and all of that kind of jazz. Cool? And then we said, okay, well, this thing right here ends up being x plus 3 squared. Right? And notice which number went in here. The number that went in here was actually the b over 2. Because b over 2 is 6 over 2, which is 3. That's the number that goes in there. And after the dust has settled on our quadratic equation, whatever, this is the x-coordinate of our vertex. Because remember, the vertex moves it right and left, and that's the stuff inside the parentheses. In this particular case, you would be moving it to the right or to the left? To the left 3 times. So this number right here tells us, it tells us where the vertex is. And you're right, Sophia, actually, you got a good point. Why does this thing have to be the number 1? Well, okay. Oh yeah, and then what you're saying is, but what about the negative on the left side? Well, what I would do is I would make this negative and make this positive. And there's now a positive y on the right side. So this graph apparently is a graph that is flipped over. No, yeah, it's flipped over, and it is moved up to 9, and it's moved to the left 3 times. Here's what my graph would look like. Flipped over, left 3, 1, 2, 3, something like that. Try Desmos this. X equals negative x squared minus 6x. Desmos that, and you'll see that I actually got pretty close. But here's my point, okay? If you're given this, and this might be a cool trick. If you're given this, then I'll tell you a quick formula for finding the x-coordinate of the vertex. It's negative b over 2a. That's it. Negative b over 2a. And where did I get that? Well, that came from that completing the square trick. Why does it have an a over here? Because I remember that having a b over 2 and then squaring that, right? Well, it has the a over here because yes, there's 2 good ways to explain this. Okay. It has the a over here because that would be like if there was not just a negative, but there was like a negative 3 or something like that. Then we would want, what we'd want to do is we want to divide everything by negative 3. And so that's why I would have to divide the 6 by negative 3. Does that make sense? So that's why there's the not just b over 2, but it's b over 2a. And then what's the negative for? Well, the negative is, that accounts for that weirdness of moving things right and left. So in the next one, I think that it was positive x squared minus 6. And so what is the y value, or what is the x value of the vertex in this case right here? What's b? Negative 6. So what's negative negative 6? That's positive 6.
Mhm.
Divided by
So
2
it's 3.
times 1.
Oh.
3. So the x value is, x vertex is 3. And what is the y value of the vertex? Well, all you do is you plug 3 into here. So that would be 9 minus 18, which is negative 9. So the minimum of this, the vertex happens to be at 3, negative 9. And we know that it's a positive upward parabola, so it's right there.
Mhm.
Are we cool?
Okay.
I think another way to show you where this thing comes from is this. Here, I'll show you another way. The quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? This right here this right here is where I get those two answers from, because the quadratic equation always gives me two answers, right? But what happens if I don't have two answers? In fact, what happens if I'm looking specifically at the vertex? Well, in that case, I can get rid of this, because I don't want two answers, it's just one. Negative b over 2a. So if you want the x-coordinate of the vertex, you can just plug it straight into the formula, negative b over 2a. Why didn't I teach you that formula before? Well, mainly because I try to teach you as little and few formulas as possible. Because I don't want you to have to memorize a different formula for every single scenario. You know what I mean? I don't think that's fair. I think that you'll forget that formula. I guarantee you'll forget this formula if you're taking a test. I barely remembered it. But I would learn how to complete the square, you know? And if you complete the square, you'll be able to figure it out. But there is a formula for doing that. So anyway, hopefully that helps. All right.